Hello viewers, my name is Taimur Shafiq and this channel is to support students of HNC, D, Electrical and Electronics Engineering and Mechanical Engineering in different modules under Pearson exam board. This particular playlist will have videos about Unit 2 Engineering Maths in both Electrical and Mechanical Engineering HNC, D. So I will first go through the module descriptor for Unit 2, and it's broken down into different topics, and then we will have one video per topic. So let's see the module descriptor for Unit 2. Yeah, so if you can see the module descriptor, it's broken down into 4 learning outcomes. Each learning outcome normally is one assignment. So if we talk about the first learning outcome, identify the relevance of mathematical models to a variety of conceptualized engineering examples. And if we expand it, it contains the topics like dimensional analysis, APs, arithmetic progressions, geometric progressions, and the functions like exponentials, trigonometric, hyperbolic functions, and so on. The learning outcome 2 is more of an investigate applications of statistical techniques and to interpret, organize, and present different types of the data. So summary of the data using mean and standard deviation of grouped data, Pearson correlation coefficient, linear regression, charts, graphs, and tables to present data, probability theory with both binomial and normal distribution. And the third learning outcome is more about waveforms. So sinusoidal waveforms, sine waveforms, their applications, trigonometric and hyperbolic identities. Then we talk about some vector functions, vector notations, representing quantities in vector notation, vectors in 3 dimensions, and then we have the fourth and final learning outcome, which is calculus. So differential and integral calculus. So more of a differentiation and integration. We'll go deeply into integration and differentiation when we actually do the learning outcome delivery. So in this video, I will start talking about the learning outcome 1 and the first topic in the learning outcome 1, which is dimensional analysis. So let's have a look at the dimensional analysis. Right, so dimensional analysis in engineering. Very often the calculation in engineering and science lead to a result which not just a pure number, it's not just a pure number. For example, if we were measuring the distance covered on a road and we say 5, that doesn't make sense unless we say 5 meters, or if we say we have a weight to measure 37 on a weight scale. That doesn't make a sense unless we say 37 kg. So as we know, these meter and kg are the units. So analysis of the units in such a way that we can check the validity of the formulas, equations, etc. Basically, the equalities, both sides of the equalities can be tested in terms of the units. This analysis would be called dimensional analysis. Let's talk about an example, how we are saying the validity of a formula and blah, blah, blah. So let's go and look at an example. We have an equation, constant acceleration equation. So constant acceleration equation. Which is S is equal to ut plus half a t square, where you know that u is initial velocity, t is time, and a is acceleration. Sorry, a is acceleration. If my spellings are wrong, just forgive me. I'm terrible with the spellings. Right, so we're checking about the validity of the formula. So that means the units on the right hand side should have the units of the left hand side. So I mean the ultimate units of the left hand side. Let's observe. So talking about the units, S is what? A distance, and should be measured, if we talk about the System International Unit or SI unit, it should be measured in meters. So ultimate response or ultimate answer from the right hand side should also result in meters. So let's have a look. On the right hand side, what do we have? We have u, the first parameter, which is velocity, and we know that the unit of velocity is the meter covered per unit second, or velocity or speed is the meter per second. So we've got meter per second. We also have with velocity time, and we know that time is measured in seconds. So velocity times seconds, which is time. Okay, and then we have add, and half is a constant which doesn't have any unit. So since we are talking about only units, we've not talked about how much the magnitude of these two parameters will be. We'll ignore the magnitude here as well. So we'll only talk about the units. Let's talk about the units of acceleration then. Acceleration is measured in meters per second square. So I have meters per second squared here, and the final one I have is time squared. So I know that the unit for time is what? Second, and because it is squared, so it will be squared. So I have second squared here. Now solving some basic arithmetics, I know that this second will be cancelled by that second, and this second squared will be cancelled by that second squared. Ultimately, I will have a meter plus a meter. So how many meters? I mean, whatever the magnitude there is, the answer will be the unit of meters, which is what we wanted on the left hand side, a distance which is measured in meters as well. So that means that we have verified that the left hand side and both right hand side will produce meters. We're not sure about what the magnitude on the right hand side will be or how many meters. However, the formula is correct as it is producing meters on both the sides of the equality. Let's have a broad view of this concept. So in terms of the dimensional analysis is done on a few rules. So there are 7 fundamental dimensions. Based on which we try to derive the rest of the dimensions, just similar to how your derived units work in line with your fundamental units or your base units. Okay, however, out of them 7, the most important ones are length, mass, and time, which we will discuss in this particular course. So these are the 3 dimensions as you know, length is the dimension for distance or meter. Mass is the dimension for mass, which is a quantity. And time is the dimension for time, which is a quantity itself, or its unit is second. All right, so these are the three fundamental dimensions. We will have a look here. When doing the dimensional analysis, we try to use these brackets. So, for example, length, mass, and time, so that we know that we are doing dimensional analysis of a particular thing. So big brackets or these parentheses will actually represent the dimensional analysis. So let's do the dimensional analysis of force. To do the dimensional analysis, we must first establish a relationship or dependency of the particular formula or a particular parameter. So we know that the force is given by the second law of Newton, as in mass times acceleration. Then what we would do is we would check whether these two lie in one of them or not. If not, then we will go further down, checking this one. This lies in here, so we're not very worried. We will just replace that with this when doing dimensional analysis. However, this one does not, we're not able to find in here, so it is acceleration. So what we will do, then we will find out the formula or equation for an acceleration, and we know that acceleration is what? Distance covered per unit time squared, or you can say velocity per second. So distance per second squared, or you can say meters per second squared. So that's meters, which is a length, and length exists here, and that's second, which is time, and time exists there. So that would be length divided by t squared. Now we know that we will replace this one by that, and we'll replace this m by that. So let's have a look. F dimensional analysis will be m and l, m l divide t square, or in a simplest form you will write mlt minus 2, and you will combine the bracket. So that will be the dimensions of force. Let's do another example. Just before we do another example, the rules which we've used is the rule 1, that the dimensions of the constant number, there is no dimension of the constant, so we will ignore the constant. So constant numbers in formula do not have dimensions and are ignored. And rule 2, angles in formula do not have dimensions. Then there is a rule 3. And rule 3 is, in a formula, only physical quantities with the same dimension may be added or subtracted. In formula, only physical quantities with the same dimensions will be or may be added or subtracted. So based on these three rules, let's do another example, and then that's me concluding the lecture, and then I will give you some homework, or let's say an assignment for this particular lecture. Right, so state the dimensions in terms of m, l, and t. So I have a question that I have to say the dimensions of pressure. Sorry, I'm just trying to paste this question. So I have a question, state the dimensions of, in terms of ml and t, pressure, and I've been given that pressure is what? Force per unit area. So I know that pressure will be dimensions of force per unit dimensions of area. Do we know the dimensions of force? We've just worked out the dimensions of force. If not, then I will tell you how you would do it again. And I know that area is what? Length times length. So that will be L squared. So MLT minus 2 over L squared. That square cancels that. So I have MT minus 2 over L, or what you can do, ML minus 1 T minus 2. Always use brackets so that you know you're talking about, or the observer knows you're talking about dimensional analysis. However, if you don't know this, then you know that F here, pressure is equal to force per unit area. So first find out for force. Force is equal to mass times acceleration, and acceleration is what? Speed per unit second, and speed is what? Meters per second. Right, so we'll go back. Meter is what? Length. Second is what? Time. These are both fundamentals. And that's velocity. Put velocities in here. So I've got, for acceleration, I will have L over T. Then this T will be separate. So you will end up concluding that A is equal to L T L divide T squared. Put in L divide T squared. Okay, substituting the acceleration in there, I will have m for mass and L divide T squared. Then I can write MLT minus 2 when you move it up, similar to how I mentioned it here. Similarly, for area, you would say area is equal to length times length. And if we're talking about dimensions, that is L squared. So this is the same as how I did this one. So your assignment for next week, or before we meet up next time, is to find out the dimensions of, in terms of ml and t, the dimensions of all these equations. I have given you the relationships. Just a second. So you have to find out the dimensions of all these. A I've done, and you have to do B to G. Thank you very much. I will see you next time with a bit expansion on the topic of dimensional analysis, so we could move forward from P1 to maybe M1 in the unit 2. I will see you in the next video. Thanks for watching. Bye.